Hello everyone and welcome to our Fenix Research Infrastructure webinar of today. The title is Introduction to the JUSUF system at the Juelich Supercomputing Centre, and this is the sixth webinar in our webinar series. You can find more information on this webinar series on our website, as well as the previous recordings and presentation slides, but I will share more information about this with you later on. Our speakers for today are Benedikt von Senbich and Pavel Mechenchev from Juelich Supercomputing Centre, who are going to share with us their technical presentation. And I'm Nicoleta Chiapidou. I'm a member of the dissemination team of the ICI project based at BSc. So just to let you know that the webinar is being recorded. So that's just in case you are going to share any personal information when you ask a question or you make a comment during the Q&A section. And the structure of this webinar is as follows. Right after my very short introduction now, Benedikt and Pavel are going to present their slides, and right after we will have a Q&A, so a dedicated time for any questions or comments you might have. And in the end, after the Q&A is over, I'm going to share some more slides where I will talk about the access to our resources, our contact details, and some more relevant information. So stay tuned until the end. So we can start with our presentation now from Pavel and Benedikt. Okay.
Great. So me and Benedikt are going to tell you about the JUSUF system in Forschungszentrum Juelich. So there are going to be several parts. So we will start with the overview. What makes this system somewhat special is the fact that it consists of two partitions, so the regular HPC cluster and also a cloud partition. So we'll describe each part in the presentation. So let's start. So the name JUSUF stands for Juelich Support for Fenix. So yeah, as I mentioned, it's a hybrid HPC cloud system. So you can see some general information on this slide. So let's move on. So primarily, I would like to talk about the hardware. So this is our first system on AMD EPYC CPUs, and we were quite excited to get such a system. So it consists out of 205 nodes. Each node is a dual CPU system with 256 GB of RAM. Out of these 205 nodes, there are GPU nodes. So each GPU node is equipped with one NVIDIA Tesla V100 GPU. Fabric-wise, all nodes are connected via Mellanox HDR InfiniBand, so it's a full FAT3. On the node level, it's HDR 100 in terms of speed, and then also there's a 40 gigabit connection to the storage network. So all systems at our research center use GPFS. Then the system, I'm sorry, there is some noise in the background. I apologize
no
for that.
problem.
I hope
we can hear you well. Yeah, no worries.
Yeah. So for the cluster partition, there are 4 front-end or login nodes. So these are part of the regular, the HPC partition. Then in terms of storage, so we have the main GPFS storage, and also there's another used IME partition. This one can be used as a transparent cache, and it has the potential to speed up the I/O operations. So if your workload relies on heavy I/O, then you might want to consider giving it a try. So yeah, now moving on, a little bit more information about the CPU. So this is the well, top of the line AMD EPYC CPU. So it has 64 cores, which gives a total of 128 physical cores per node. And with SMT enabled simultaneous multi-threading, we get 256 logical cores. So the top performance that the peak performance is 4.6 teraflops, which is well, quite significant for a single node performance. And also uses PCI 4.0. So since the nodes are equipped with NVMe disks, there's potential speed up there as well. Okay, now let's move on to the cluster partition. So as a users, well, what I'm going to do now is to try to cover the most relevant parts that you might be interested in as users. So how to get access to the systems, how to use the system, some basic things to get you started, and I will provide the links where you can get additional information. So to access the system, there is a centralized portal in Research Center, the UDOR, so you can see the link on the screen. And also, since the JUSUF system is part of the Fenix, also additional information can be found on the website in the bottom. So as I mentioned, there are a few login nodes. So generally, you would want to use yusuf.fz-juelich.de as an access point. However, in some special cases, you might want to access a particular login node. Then that can be done via a direct link. So currently, there are certain restrictions in terms of access. So the general rule for all our systems is that there are only key-based authentication is supported. So username and password is not supported. Then there's also a requirement that the users need to protect their keys with passwords. And they also need to provide a set of hosts or subnets which are used to access the system. So that can be either the IP address of your home router or the subnet that is used at your organization. So the access from any random host is not allowed. And also the manual modification of any of that access information is not allowed. So all the access information is managed by the UDOR portal that was mentioned on the previous slide. And if you want to make any modification, you have to go to the portal and manage it there. Then another thing that is supported is Jupyter Hub. More information can be obtained on that link. And we also support Unicore for human brain project collaboratory access. Okay, so moving on, once you are on the system, so in terms of environment, there are modules. So you can take a look at the list of the available modules and, well, hopefully find everything that you need there. So it is used to set up your environment, starting with the compiler and MPI. And a lot of other software is also pre-built with corresponding versions of the compiler and MPI that you choose. So that way, you should be able to set up the environment. Also, that software is bundled into stages. So approximately every half a year, there's a new stage that is rolled out with the updated versions of the compilers, MPI implementations, and other applications. Then, well, in terms of compilation, it's, well, somewhat straightforward and, well, hopefully familiar to most of the users. So yeah, there are those wrappers around the compilers that provide support for MPI. you can see here. So yes, I think that is more or less it. So the next part is the batch system. So Forschung Centrum Juelich, here we use Slurm on all our computers and all our systems. So it is used together with Parastation Resource Management System, which is developed together by Juelich Supercomputing Centre and Partech. If you happen to be a user of other supercomputers like Jules and Eureka, then you will find that there is an identical environment that should be really familiar to and should be easy and straightforward to transition from one system to another. So job scheduling happens according to priorities. So that kind of depends on the project, according to which your resources, the compute time is allocated. Then there's backfilling. So if there are available resources on the system, then your job may still get scheduled if there are enough resources for it. And yeah, then there is no node sharing that is not supported on our system. So the minimum allocation unit is 1 node. So even if you're using your resources, like just 1 core, then you still get 1 node. Yeah, and then, yeah, in terms of accounting, it is done in core hours. So yeah, you can see the formula on the screen. So then in terms of partition, so we have 3 partitions. So as I mentioned, we have 2 types of nodes, the regular CPU only nodes and the GPU nodes. They have the same CPU, amount of RAM and so on. So the only difference is that they're equipped with one B100 NVIDIA GPU. So to use those, you submit your jobs either in the batch partition, which is the default one, or in the GPU partition if you plan to use the GPU and your application support it. Also, there is a small devel GPU partition which can be used for testing. So there, generally, your waiting time should be smaller, and kind of then the jobs will run faster. Yeah, so that's the high-level overview. Yeah, so that part should be familiar to users who have some experience with Slurm. So the only kind of part that is specific to our research center is that first the user needs to set up his environment and specify which project wants to use so that the resources are allocated from the right project in case, for example, a user has access to several projects. And then there are, well, a few simple examples how job submission looks like. So yeah, the user has to specify the number of nodes, the number of tasks per node, any additional resources like GPUs, the wall time limits for a job. And then, so how it is usually approached is the user creates a job script. An example is given on the bottom of the slide. There, a user has an opportunity to specify additional parameters. And then ultimately that script will be executed, and once the resources are available and they're allocated to the user, his job, his application will run. So and this is, I understand that this is, well, quite a high level overview, but we have a detailed documentation available by the UDOR portals and have user support. So and if there are any additional questions, we will be happy to provide support and help you get started. And yeah, finally, this is a slide that was shared with us by one of our colleagues. So he was experimenting with the Nest application, and he was happy to report that he was quite satisfied with the results that he was able to achieve on the system. Again, if there are any specific questions, we would be happy to forward it to him. But yeah, what like he emphasized is that he was really happy to observe that the performance, so this real-time factor, is close to 1. So well, as we've been told, that is something that the Nest users are aiming for, and he said that this was a significant improvement compared to other supercomputers that are available to him. So, and yeah, as you can see, and kind of he did quite some job with in terms of tuning, and was able to find a good combination of compilers and MPIs and other parameters. And yeah, in the end, he was able to get well, a certain improvement in terms of performance, and yeah, was happy with the results. So yeah, that concludes the overview of the cluster part. So yeah, now I will let my colleague Benedict continue with the cloud part.
Yeah, hi. Welcome from my side. My name is Benedict von Sankfried, and I will now give you some information about the JUSUF cloud. It was built up in parallel to the cluster, and it's running on the same hardware, at least the same type of nodes, but we try to separate them as much as possible due to security concerns. I will not dive into cloud computing in general in this talk. There was the 5th Fenix webinar where cloud computing was addressed. I think it was by CSCS, which introduced their Pollux system, and they also gave a live demonstration about the OpenStack dashboard. So if you want to see some live cloud behavior, take a look on that video. I think it was a really, really great presentation. The only slide I borrowed from that presentation is this one. Because it actually shows what we want to provide. So I think most of you know these kinds of different, let's say, levels. What we within Fenix provide is basically infrastructure as a service. So on the cluster partition, we simply provide a computing time. So you can do whatever you want with your computing time. Here for the cloud, we provide infrastructure as a service, which is in some way also computing time. I mean, we provide you with virtual machine cores. We will provide you with block storage and some kind of network devices. But the way it is provided is slightly different than from the cluster partition. How to access the cloud? The resources are made available via Fenix and price calls. So you usually have to apply for a specific amount of resources. As I said before, you give a number of CPUs, some amount of memory and block storage, and you will hopefully then receive the okay from Fenix. They will provide us the information about you so that we are able to actually give you access to the resources. And then when this worked, you can directly access them. Users of the cluster do not get automated access to the cloud because it's a completely separated offer, so to say, of course, within Fenix, but yeah, it's simply a different offering. Here is the URL for the dashboard. If you try to go there, you can either access the cloud via the Fenix AAI or via our local user accounts, because the Fenix AAI is not covering all, I think not even all human brain sites. So we also made the access via user available. The full system documentation is available at that specific link. I mentioned this because later on I will give a short presentation on how to actually get a VM. So I will not give a live demo, but only show the commands. But the full documentation is available on our web pages. There is also a short introduction on how to actually interact with OpenStack and what basic steps are usually necessary. If you have problems when you use the cloud, or if you have questions, feel free to contact our application support. There is a dedicated queue for the cloud where we will answer your questions. The workloads that we expect on the cloud are, of course, several platform services like the Human Brain Platform, several different kind of web services, databases, repositories. Yeah, I mean, this is simply usual cloud workload. Cloud, of course, is simplified. I mean, you have offers with VMs and with containers, but usually, or what you run typically very often, are some kind of databases and web services on top. We also provide compute and analytic workloads. This is shown later. The underlying technologies and some of the design considerations we had. So our offer, so the JUSUF Cloud in general, is based on OpenStack Platform 16. It is the OpenStack train release. For our deployment, this is only for the technical stuff, which is hopefully also participating in this webinar. The deployment is based on OpenStack 000. So in fact, we have two clouds. One is for us as operators, and one is actually for you as the final users. The deployment is fully containerized, and we use Red Hat Enterprise Linux 8, so the latest release. What's different for the cloud with respect to cloud offerings by Amazon or Google is that we don't overcommit resources. So let's say you request one CPU, you will also get that one CPU. It's different with respect to normal cloud providers. They usually overcommit resources. This was I think a decision by Fenix. So it was not a decision by us to go that way. What we use within the cloud is NFS as a storage backend for the VMs to be able to provide you live migration. Due to that, we have the limitation that we don't have copy on write. So whenever you spawn a VM, it might take a little bit longer than on some other sites, which may use different storage backends. You might notify that, but not necessarily, because we, as Pavel showed in the beginning, have some, let's say, fast network links, which hopefully partially hide this delay. Yeah, the node layout. So what we provide you, or what JUSUF provides, is a mixture of cluster and cloud resources. Due to that, and as you have seen, the prime contractor was Atos. They are very, very good in providing you an HPC cluster, but it looks like cloud workloads is not their main focus. And of course, I mean, we designed the system in a generic way that it can provide both workloads. This means that some of the decisions are not optimal for a cloud workload. So to give an example, we don't have full network redundancy down to a node level. This actually might influence you when requesting resources, because you might have to request additional resources to make your service highly available if you really target to make your platform available 24/7. Some words about the network. So whenever you spawn a VM, you are usually in your private network. You are able to access floating, to assign floating IPs to your VMs. So to give your VMs simply a publicly addressable network address. You see the subnet here, which is just a technical detail, I would say. I mean, when you create your VM and associate the IP, you will simply get it. Together with a host name, which is in our FTJ network. So we have to report every floating IP that you allocate to our IP management. Due to security constraints, you are only allowed to use specific ports for your VMs. So in fact, you can use every port you want, of course, but not all ports are available from the outside. So if you want to provide a web service to the whole world, you have to pick one of those specific ports. And of course, SSH, because whenever you spawn a VM, usually you go there at the beginning at least via SSH. The flavors that we provide within our cloud are listed here. You will see that the ratio between cores and RAM is yeah, at least factor of 3, I think, maybe even more, which is, if you followed Pavel's slide at the beginning, a bit bad, because we in the cloud we use also SMT, so we handle them as real cores, so to say. So in fact, we have 256 cores within a server and 256 gigabytes of RAM, which is a bit unlucky. But anyway, what you also see here is our, let's say, special hardware. So we have inside of the nodes NVMEs, if you need fast storage, and we have virtual GPUs. As I mentioned before, one of the workload within the cloud might be data analytics or simply compute. There you usually use a vGPU, which is not behaving as a full GPU, so to say. So Pavel mentioned that we have GPUs, I think, with 16 gigabytes of RAM. So the vGPUs are only able to allocate 4 gigabytes. So in fact, one GPU can be used by, I think, 4 users or shared across 4 users. All of them see the GPU as a dedicated device, but in fact, the GPU is shared. For the NVMe, this is not true. So the NVMe is a dedicated device. Some words about those specific hardware types. The amount of resources is quite limited here because of the underlying hardware. vGPUs have a very limited live migration support. This is simply a limitation which is simply done by Red Hat and NVIDIA. So we are not able to influence that in any way. We simply have to live with it. And we can only give you the recommendation, please try to make your workloads easily redeployable and don't use those specific hardware types if you really plan to be available 24/7. Because when we do a maintenance on the underlying cloud infrastructure, we usually try to move your VMs around so that they don't go down while we are doing maintenances. But in case of vGPUs and NVMEs, this is simply not possible due to hardware limitations and partially also software limitations. One short example about how to start a VM with a vGPU. What you see here, yeah, you see my mouse pointer. Here you simply create a server with a GPU flavor, a random CentOS image, and the name, whatever. Inside of that VM, you have to install some packages, download the driver that we provide for you, and you have to install it. Currently, we do not plan to provide you with finally usable images to simply move away this maintenance effort from our side. This might change might change in the future. If you follow those steps, they are only partially written here. There is not much missing, but at least a little bit. The full example is given in the JUSUF Cloud user documentation on our webpage. At the end, if you follow those steps, you will simply see the vGPU within your VM. So you will have a PCI device, the Tesla V100, here mentioned with 16 gigabytes. But if you see the NVIDIA output, you will simply see that you get 1/4 of the available memory. Yeah, this as a short example. If you have further questions, feel free to contact me or feel free to contact us. And looking forward to see you as a user of the cloud.
Okay, thanks very much, Pavel and Benedict, for your presentations. Very informative and very useful. I think we can go ahead with the Q&A. And I have already seen a few questions in the chat, which I'm going to read out loud, and then there are a couple of more people that would like to ask a question. But first, let's go ahead with the ones in the chat. So there is one that says, what Nest code was run?
Yes, so on JUSUF, the latest and greatest results were achieved using the latest master version 2.20.1. So I was also informed that with an older version 2.14, I think there real-time factor was lower, so it was something around 0.64. So yeah, part of the performance improvement is thanks to the improved code, and well, part of it is to the system providing good level of performance. So I hope that answers this one.
Good. And there is another one saying, if you could provide more details about the nest on the JUSUF tests and on who carried out the tests, if you can give any.
Well, I don't think I'm comfortable disclosing the developer here, but if you could send me an email, I would be happy to get you in touch with him, and yeah, then I'm sure he will be able to provide more details.
Okay.
So yeah.
Mm-hmm. Then there is another question that says, can you communicate between the two partitions? Are there any restrictions?
I might answer this. So as I said, the systems run on the same hardware, but we try to separate them completely because of security reasons. So in fact, the only way you can follow is the usual way between those networks. That means you can access from the VMs the use of login nodes via SSH. But beside of that, there are no additional access paths between those two partitions of the JUSUF.
Thank you. And then I go on with the chat questions that came during your presentation. There is one that says, is there a CLI access and whether all ports are available to the HPC partition?
Yeah, CLI access, it depends. I showed in the slides and also in the documentation we mentioned this. Currently, the Fenix AI is not supporting the command line interface. This might be brought to the users later on. At the moment, it is not available. So if CLI access is something you really need, and if you can show us reasons for that, we can add you to UDOR. So give you a UDOR account where you then can use the CLI. For the Fenix AI, currently only the Horizon dashboard works. That was shown in the CSCS presentation. About the ports, I am not sure what this means.
I think Ellen, you need to read out the question first, because maybe not everyone sees it.
Yeah. Yes, so the question was, are all ports available to the HPC partition? But I think the person that asked this says that it was answered by your first response. But yeah, you can add anything, of course.
Okay. Yeah, I mean, as I said, the cloud can access the cluster via SSH, via the login nodes. The other way around, I think due to a security incident we had, outgoing access from the cluster to anything else on the internet is currently blocked. So if there are workloads requiring such kind of network traffic, this is to be discussed simply.
Thank you, Benedict. So we have a question from someone that would like to speak out loud. So I'm allowing now the person to talk. Can you hear us?
Yes, hello, can you hear me?
Hello, yes.
Okay, yeah, hello, thank you for your presentation. I was wondering if you have some kind of plan for deploying a subset of tools from eBrains recurrently on the different stages of JUSUF, like Nest, for example, or the many other simulation engines that are of relevance for us in order to build on top of that, because that would be really helpful to just do module load tool, and then we could then have our workflows running on top of that.
What means that?
Yeah, so running on top of your installation as modules. So if you plan to install on every stage a subset or a specific set of software tools that are of relevance for the HPP.
With stage, you mean the easy build stages within the JUSUF cluster, right? So you
Yes.
are not talking about the cloud partition.
No, no, no.
Okay.
About the cluster.
Okay. I think we cannot give a clear answer here. It's a site specifica, right? So we are talking about the JSC site.
Yes.
I think in the past, the goal was to find software responsible persons for the different easy build modules. And if we have, let's say, person who's responsible for some kind of HPP related software within one of the clusters, of course, I think this person can also bring the same module to JUSUF. That's for sure. But I think it's at the moment not the goal of either myself or Pavel to provide something like that. So it's simply on the JSC support stuff to bring this to easy build, if this is let's say agreed on.
Okay. So let's say if I would need to have Arbor installed on JUSUF, I follow the same procedure as with Eureka or Juwels, or contact SC, and then they could probably add this to a module in JUSUF.
Exactly.
Individually, let's say. Okay. Thank you.
Thank you. There's another question in the chat that's from before. So they ask for a few more information on what nest model was used and how many neurons and synapses connected how a balanced random network model.
Yes, I'm afraid I don't know these details. Yeah, if you could follow up with an email, then I would be happy to put you in touch with the colleague who ran those tests, and I'm sure, yeah, he will provide the information.
Right. Thank you, Pavel. There's another one in the chat again that says, does that mean that the GitLab runner, for example, on the HPC partition would not work? It communicates over HTTPS, probably, and if it was linking to the cloud infrastructure.
Yeah. If you spawn a VM in the cloud and open the port 443, so HTTPS, the GitLab runner would run on the logins. At least I assume that. It's not officially supported by us, but it could be the case that some user does this. And if this GitLab runner then uses HTTPS to communicate to the cloud, and you open the cloud, the VM port beforehand, this would work. Not from a compute node, because we usually don't forward all traffic, but from a login, this should work. Yeah. And if not, we have a bug in the firewall. Or you did not open the port in OpenStack. That's the two cases could occur.
Thank you. So if there are any other questions, we have a bit more time. What about CVM FS support on the cloud?
Yeah. I mean, you can spawn a VM and you can do within the VM whatever you want. So to the outside world, we don't have limitations. This means you can consume from the internet whatever you want. So if you install the corresponding software and have the corresponding amount of storage available, you can mount it. Whether you can provide it to someone in a useful way, I don't know, because the VMFS is too far away from my, it's not my best expertise, so to say. Within the VM, you can, as I said, do whatever you want. and access most of the internet. So, yeah.
Okay, I think if there are no more questions and comments, I can go ahead and share my final slides. So just wanted to say a few more things about the access to the Fenix resources and services, and Pavel and Benedict touched upon this already, but just a few more details that for neuroscientists in particular, we have a human brain project eBrains call running. This is an ongoing call and there's no deadline, so you can always go ahead and apply for this. And there is also the PRAISE ICI calls for proposals. The third round of these calls is going to be out now in the beginning of September, with a deadline to apply by the end of September. The announcement is going to be out very soon. And this again applies to researchers in any sector that are in need of scalable interactive computing resources, virtual machine services, and data and archival data repositories, active and archival data repositories. All the details on the access to our resources can be found on our website, but you will also receive an email right after this webinar with all these links and the information, so you will have everything in hand. I just wanted to thank our partners for making this webinar series happen, and of course our speakers today, Benedict and Pavel, and all of the attendees that took part in the webinar. Just to let you know, our next webinar is coming very soon on the 22nd of September. It's titled Introduction to the ICI Resources at CEA. There's going to be a presentation by Thomas Leibovici from CEA. And you can already register. Registration is free, but mandatory, and more information will be sent to you again in the same email. But there's also information and the registration link on our website under events. We would really appreciate your feedback on this webinar. So if you could please take a couple of minutes to respond to our survey, it will be sent to you in this email, but there will also be a link opening up on your browser after this webinar. So if you can please take some time to reply to this, that would be great, so we can improve our trainings. Finally, we have a communication platform up and running for Fenix users. We call it the Fenix User Forum, and it's very easy to register. You can see here the link. Again, this will be sent to you in the informative email. So it's a platform where potential or current users of the Fenix resources can sign up and have discussions on our services and resources and ask questions. And you will also have access to dedicated user documents, a calendar for our user, dedicated events and meetings, and so on. And finally, here I'm sharing some contact information. This is our email. You can always email us with any questions about what you heard today at this webinar, but any other doubts you have on how to use our services or on how to access them. Visit our website, all the information is on there, and also follow us on Twitter for any updates and news. And with that, I would like again to thank our speakers, our partners, and all the attendees for attending, and stay tuned for the full recording and presentation slides to be uploaded on our website very soon.